Well, this screencast is devoted to what we do to estimate sums and differences. What if we don't really care what the answer is, but we care about how big the answer is? So just a couple of examples to illustrate. Let's estimate 25/12 plus 8/7. Let's estimate about how big is that? Well, we know that 24/12 is 2. So this 25/12 is 2 1/12. And we know that 7/7 is 1. So this is 1 1/7. So about how big is that? Well, this is a very small fraction. This is a fairly small fraction. So that sum is about 3. 1/12 and 1/7. This is very, very small. This is very, very small. They almost don't matter. That sum is about 3. It's probably less than 3 1/4. Similarly, let's estimate. Let's estimate 4 4/5 plus 8 1/2 plus 1 2/5 plus 3 1/4. Let's estimate. About how big is that? This turns out to be a scenario where we look at those fractions. Those are both very close to a half. That is a half. This is very close to a half. And then we look at these fractions. This is very close to a whole, and this is very close to 0. So these two together are about 1, and these two together are about 1. And so what do we got? 4 plus 8 plus 1 plus 3, and then the green one and the red one. So that's 12, 13, 16, 17. It's about 18. So this sum is about 18. It's not, but if we were estimating, we could estimate that's about 18. The strategy here that we use is what your author calls grouping to nice numbers. We look at maybe three fractions that are all about 1/3, and we add them up to 1, or we find a fraction that's really close to 1 and a fraction that's really close to 0, and we say that their sum is about 1, or we find fractions who are all about a half, and we treat them as if they were, and that gets us in a close enough ballpark to make decent estimations. Okay, hope that's helpful. We'll see you soon.